Good morning to all. Good morning to all. I am Sumati. In this video, going to discuss about communication satellites and its types. Communication satellite is an object that revolves around another objects like planets. Artificial satellites that are used to relay and amplify signals for communication. The communication satellite in station is working as a station in space that is used for telecommunication, television, radio, internet, GPS, and military purposes. Orbit Earth at different altitudes and speed depending on the use case. This is how the communication satellites works. The user can communicate using voice signals, data signals, or TV frequencies, and these signals are passed to the terrestrial system, and the earth station sends the signals to the antenna placed in the earth station, and the antenna sends to the uplinks to the satellite, and from the satellite the frequency is relayed back and it is amplified there, and the receiving station, earth station, receives the signals and it is transmitted to the user. This is how satellite communication takes place in earth. Satellite communication is used for transporting information from one place to another using communication satellite placed in the orbit around the earth. The communication satellite is an artificial satellite that can transmit the signal via transponder by creating a channel between the transmitter and the receiver at the different earth locations. Telephone, radio, television, internet, and military application uses satellite communication. In early 1950s and 1960s, metallized weather balloons were used for communication, and later on moon is used as an artificial satellite by Naval Research Laboratory in US in 1954. But unfortunately we met disadvantages, and this disadvantages prolonged to use satellite communication for a maximum distance of 1500 kilometers. The procedure of satellite communication is similar to that of space mirrors that help us to bounce the signals such as radio, internet data, and television from one side of the earth to another. There are three stages involved. They are uplink, transponder. The second stage involves the transponders such as radio receivers, amplifiers, and transmitters. These transponders boost the incoming signals and changes its frequency so that the outgoing signals are not altered. The final stage is the downlink, in which the data is sent to the other end of the receiver on the earth. It is important to understand that usually there is one uplink and multiple downlinks. This is the process how the satellite communication takes place through uplink and downlink. Here uplink signal is 5.9 to 6.4 gigahertz, and the input filters the signal, and amplifier converts the signal, strengthens the signal, and it is sent to the multiplexer, amplifiers, and output multiplexers, and it is sent again as a downlink signal. These are all the various satellites communication helping us to communicate in India. There are two categories in which satellite communication services can be classified. One is one-way satellite communication and the other is two-way satellite communication. In one-way satellite communication takes place either between one or multiple earth stations through the help of satellites. The uplink is one-way communication and the downlink is also one-way communication. Here the transmission takes place between the first earth station and the second earth station through satellites. In two-way communication satellite, the information is exchanged between any two earth stations. It can be said that there is a point-to-point connectivity. The signal is transmitted from the earth station to the second earth station such that there is two uplinks and two downlinks between the earth station and satellite. Here we can notice that there are two uplinks and two downlinks in these earth stations. Active satellites receive, amplify, and retransmit the signals. Here, this active satellites acts as an electronic repeaters, whereas passive satellites simply reflect the received signals without amplification. The functions of active satellites is to receive, amplify, and retransmit, whereas the passive satellites just reflects the incident signal without amplification or processing. The advantage of active satellite is it is stronger signal strength, allowing for wider coverage and more reliable communication. Advantage of passive satellite is it is simpler in design and construction, whereas disadvantage of active satellite is requires more complex onboard equipment and power sources. The disadvantages of passive satellites is weaker signal strength, requiring more powerful ground based transmitters. The key difference between active satellite and the passive satellite is given here. Then the advantages of satellite communication is elasticity of this circuits is excellent. This user fully controls this network. With the help of satellite communication, every corner of the earth can be covered. Disadvantages of this satellite communication is it is initial expenditure is expensive. There are chances of blockages of frequencies, propagations, and interference are some of the disadvantages of satellite communication. Applications of satellite communication: it is used for telecommunication, television broadcasting, digital cinema, radio broadcasting, amateur radios, internet access, military, and disaster management. Based on the satellite's orbit, the satellites are classified into GEO, MEO, and LEO. GEO is geostationary Earth orbit, which can be placed at 35,800 kilometers. MEO satellites are medium Earth orbit satellites placed between 2,000 km to 35,800 km on the space. LEO is low Earth orbit, which can be placed between 160 to 2000 km. Each orbit type serves for different application and has unique properties. The first blue ring shows the LEO orbit, and the red shows the MEO, and again the dark blue shows the GEO orbital planets. Geosynchronous satellites. This is orbitary options. Geosynchronous satellites completes one revolution around the world every 23 hours and 56 minutes in order to maintain continuous positioning above the Earth's sub-satellite point on the equator. MEO Earth orbit satellites requires a constellation of 10 to 18 satellites in order to maintain constant coverage of Earth. LEO Earth orbits offers reduced signal loss since these satellites are 20 to 40 times closer to the Earth in their orbit, just, just allowing for smaller user terminal antennas. Geostationary orbits are placed at an altitude of 35,800 kilometers. These satellites appears to be fixed over one position on the Earth. This is mainly used for TV broadcasting, weather forecasting, and long distance communication. Geosynchronous satellite has an orbital period same as the period of rotation of the Earth. Hence, it appears to be permanently in the same area of the sky at the particular time each day when viewed by an observer on the Earth. The orbit in the geosynchronous satellite is called geosynchronous orbit. Its orbital period is the sidereal day, that is 23 hours 56 minutes 4 seconds. Circular geosynchronous satellites, which is placed at 0-degree angle to the equatorial plane, is called geostationary satellite. It is stationary at the fixed position of the sky throughout the day by the ground observer. It is placed 35,800 km above the Earth's equator and has an orbital period equal to the sidereal day. Advantages of geosatellites: it covers large area, constant communication with fixed ground station, ideal for broadcast and weather service. Disadvantage: high latency due to distance, costly to launch and maintain. Medium Earth orbit: it is placed in between 2000 kilometers to 35,800 kilometers. It is commonly used for navigation and timing systems, and this satellites lie between two Valence belts, that is MEO, are called intermediate circular orbits. The altitudes of these satellites range from 2000 kilometers to 35,000 kilometers, and the orbital period of MEO range from 2 hours to more than 23 hours depending upon their altitude. This is how the MEO satellites are placed between the upper Valence belts and the lower Valence belts. And the latency speed is 35 to 85 milliseconds. And the number of satellites needed is 10 satellites needed around the Earth orbits. Circular orbit, and another one is elliptical orbit. So, MEO with circular orbits revolve at the constant speed at the constant altitude. MEO with elliptical orbits, lowest altitude is called perigee, and the speed is highest here. Highest altitude is called apogee, and the speed is lowest here. Advantages: it has lower latency than GEO, better coverage than LEO with fewer satellites. Disadvantages: it requires tracking antennas, higher launch costs, and the satellites moves quickly and in circular motion in 90 minutes. It is ideal for Earth's observation and broadband communication, and it lies below 2000 km from the Earth's surface, below lower Valence belt. They move at a very high speed and may not have any fixed space with the Earth with respect. This is how LEO orbits circulates around the Earth. Features of LEO satellites: the network's LEO satellites are needed for global coverage as their orbits are not geostationary. Due to their high speed, satellites move in and out of the Earth station from time to time. They are very much energy efficient. They are quite cheap in comparison with other data communication modes. They can be used for establishing network in remote terrains where there is no feasible to lay landlines. Types of LEO and their uses. It is used for communication satellites for because of low cost data communication. It can be used as earth monitoring satellites and internal space station. Advantages is it has low latency and high data rates, cheaper to deploy. Disadvantage is requires large constellation for continuous coverage, shorter lifespan due to atmospheric drag. Real life LEO examples are Starlink, which is used for global internet access, OneWeb, broadband satellite constellation, Earth observation satellite Landsat, and TerraX. Comparison of LEO, GEO, and MEO. GEO is placed at an orbit of 35,800 kilometers. The satellites placed here are fixed and high latency, and it covers a broad area, that is broad coverage. MEO satellites are placed in an altitude of 2000 to 35,800 km and a medium latency, and it is used for navigation purpose. LEO satellites can be placed in an orbital period distance of 160 to 2000 km in lower and has lower latency speed. High speed needs many satellites. To conclude, different orbits serves different communication needs. GEO is best for broadcasting and MEO is best for GPS and navigation. LEO is suitable for internet and earth observation. Understanding orbit types helps in satellite communication planning. Thank you.